Hello, my name is Matthew Anderson, and this is my lab report 2 for Physics 1. The purpose of this experiment is to determine the motion of an object falling slowly after being dropped from rest, and to compare these measurements using two computational models, one with the force of gravity and one with gravity and the drag force. Preview of the results is the model with gravity and drag is more similar to the observed tracker experiment, and the gravity-only model is less similar. Some of the equations used mainly is Newton's second law. Acceleration is based on net force and mass. This is the momentum principle, which is derived into the position and velocity update formulas. Then since the object is in free fall, you have the gravitational force and formula. And then drag force, since it is irregular object, the real world, and this increases with surface area and it opposes gravity, so there is a slow fall. Here's the experiment. The system is a paper ball. The surroundings are the earth, the air in my room, and the initial conditions are as such. And here it is again. As you can see, the y direction, there's a non-constant increase in the negative direction due to the acceleration of gravity. Here's my coding. So as you can see, here are the initial conditions and the proportionality constant, which is 0 because no drag in the first one, only gravity. And then are the position and velocity update formulas here. And then when you account for drag, it is basically the same, except for now you have the proportionality constant, which is derived by just playing around in the coding for a while until it matches the observed results. And then the net force is derived from the gravity and the drag force this time instead of just the gravity force. And the results, as you can see, the model with drag force, the red, is more similar to the yellow, the observed results, than the model with only gravity, the blue. So these two are more similar, which is what we expected. Any reasons that it's not perfect are just human errors and inconsistencies and things out of my control. The blurriness of the tracker video, the irregular shape of the ball, other forces not accounted for, like my AC unit in my room. And what does this mean? So the gravity and drag model, as you can see, it starts to taper out as the slope decreases, indicating that it will become constant and reach a terminal velocity. And terminal velocity is reached when drag force is equal to gravitational force, which it is in our case, compared to just gravity, where it's constant the whole time. What if we added an initial velocity in the y direction, throwing the ball down instead of dropping it? If it is added, the same terminal velocity is reached as the model without being thrown down. It is just reached sooner compared to being dropped from rest, which obviously there's an initial force. It's just going to speed up more quickly, but in the end, the terminal velocity is going to be the same. As you can see there, the code, I've added the initial downward negative 2y direction velocity. In conclusion, in this lab, we use Newton's second law and its derivations, the position and velocity update formulas. We use the gravitational force and drag force to model motion of an object in slow free fall. We used tracker encoding through Python and GlowScript to create a model of the experiment, and we demonstrated that drag force and gravity are opposing forces on an object in free fall.